Recording music hasn't always been as simple as opening a laptop and hitting record. For a long time, it required tape machines, large studios, and expensive equipment. Engineers would record onto reel-to-reel tape, physically capturing sound on magnetic tape that could be cut and spliced by hand. Today, most of that process has been replaced by digital tools that are faster, more reliable, more flexible, and far more accessible to musicians. To understand this shift, it helps to start with the differences between analog and digital recording. Analog recording captures sound as a continuous electrical signal, and in traditional systems, this signal is stored on magnetic tape using reel-to-reel machines. Because of the physical nature of tape and circuitry, analog systems often introduce subtle saturation and harmonic coloration, which many people describe as warmth. Digital recording works differently, by sampling the sound at discrete intervals and converting it into numerical data. Sampling rate determines how often the signal is measured, while bit depth determines how precisely each measurement is captured, resulting in a system that is highly accurate, editable, and resistant to degradation over time. Both analog and digital systems ultimately aim to capture and reproduce sound as accurately as possible, but they do so using fundamentally different technologies. At the center of digital recording is a digital audio workstation, or DAW, sometimes called DAW. A DAW is a software that allows you to record, edit, arrange, and mix audio entirely within a computer environment. It replaces traditional studio components like tape machines, mixing consoles, and hardware effects by integrating all of these functions into one system. To assemble a basic DAW setup, you'll need several essential pieces of hardware and software. You need a computer to run the system. A DAW such as Logic, Ableton, FL Studio, or Audacity as a free option. And an audio interface to convert your signals into digital audio. You'll need headphones or studio monitors for playback, and your guitar connects directly into the interface, which then connects to your computer so the DAW can receive and process the signals in real time. If you are recording acoustic instruments or amplifiers, you will also use a microphone connected to your audio interface. A condenser microphone often requires phantom power, which is a 48-volt supply provided by the interface to power the microphone's internal electronics, while on the other hand, dynamic microphones typically do not require this power. So pay attention, you'll see a button that will allow you to send power to that particular microphone when needed. Many setups also include a MIDI controller, which allows you to trigger virtual instruments, control parameters, and interact with your DAW using physical keys, pads, or knobs. This can expand your creative control and make it easier to compose, automate, and manipulate sounds beyond just recording audio. Your MIDI controller will likely connect via USB or similar to your computer directly. Sometimes, depending on the piece of hardware you are using, you may be required to download drivers or plugins to get it to function. There is also an entire world of MIDI mapping, which allows you to set the parameters, customize what each button does. We won't get into that in this video, but I want you to know that that is something you will run into. Accurate monitoring is also critical in a digital setup. Reference monitoring refers to listening through reliable speakers or headphones that reproduce sound as neutrally as possible. This means without adding anything to the sound. This ensures that decisions you make while recording and mixing will translate well across different playback systems. Digital technology also plays a major role in guitar practice routines. Within a DAW, you can loop sections of music and repeat them continuously to isolate different passages. You can also slow down audio, use metronomes and backing tracks, and practice silently with headphones, making practice more efficient and flexible. When recording guitar-related music, digital systems provide multiple approaches using both hardware and software. You can record by placing a microphone in front of a physical amplifier, or by plugging your guitar directly into an audio interface and using amplifier modeling software to capture a performance. You create a track in your DAW, select your interface as the input, arm the track for recording, and press record so the signal is stored directly in your session. As a guitarist, you might already have pedals in your setup, and these can also be used as outboard gear in a digital recording workflow. This is fun. Instead of only placing them in front of your amp, you can route signal out of your DAW and into the pedal and then back into your audio interface to be recorded again. The signal chain for this typically looks like this. Your recorded track is sent out of your interface into the pedal and returned back into a new input on your interface where it is then captured again inside the DAW. When working this way, there are a few important things to watch out for. You may encounter clipping if your levels are too hot, or added noise depending on the pedal and gain staging. And while this can sometimes be desirable for character, it needs to be controlled carefully. Microphone placement is another important factor when recording guitar. If you are recording through a physical amplifier instead of plugging directly in, you can capture the sound of the speaker interacting with the air by placing a microphone in front of the amp. This often produces a more saturated and natural tone, and blending a mic'd signal with a direct or simulated tone can create a richer and more dynamic sound. Another option is using MIDI-enabled guitars. Some guitars output both standard quarter-inch signal and also MIDI data, which allows you to trigger virtual instruments or record MIDI notes directly into your DAW. While MIDI guitar tracking is not always as precise as using a keyboard controller, it can be a powerful tool for expanding your creative possibilities, and it can capture things like bends and vibratos and subtle nuances of performances that can be a little bit harder to capture on a piano. Digital guitar technology is also widely used in live performance settings. Many guitarists use amp modelers, multi-effects processors, or laptop-based rigs instead of traditional amplifiers. These systems can run directly into a PA, and performers often use foot controllers to switch between presets instantly, allowing for consistent tone and quick transitions during a live set. Digital effects and amplifier modeling technology are key tools for shaping guitar tone. Amp modeling softwares simulate the behavior of real amplifiers, including tube saturation, speaker cabinets, and microphone placement. In addition, digital effects such as reverb, delay, and modulation can be applied within the DAW or processor, giving the guitarist access to a wide range of sounds without needing physical gear. Another major advantage of digital recording is the ability to collaborate remotely with other musicians. You can export your recorded parts as audio files, often called stems, and share them over the internet. Other musicians can import those files into their own DAW and add new parts, and continue building the project without needing to be in the same physical location, which is very advantageous. There are also platforms that allow you to work in real time remotely from different locations. The transition from analog to digital recording has completely transformed how guitarists work. Digital tools allow musicians to practice more efficiently, record high-quality audio at home, perform with flexible and portable setups, and collaborate across long distances. These tools not only replicate traditional workflows, but expand them in ways that were not possible in analog systems, giving guitarists full control over their sound and their creative process. I hope this video was helpful, and I'll see you next time.